So far, right, we've seen how to simplify the negation of a negation and the negations of conjunctions and disjunctions using De Morgan's laws. Now, the next statement on our list to do is our new conditional statement. And we can do this, but it's going to require us to think about an intermediate step first. So, seeing that these two statements are equivalent is straightforward. The left side is just the standard conditional whose results we just saw in the previous lecture. And on the right side, you can write out the complete table if you want, but we know that the P column is true, true, false, false. So not P has to be false, false, true, true. And the Q column is just true, false, true, false. Now, an OR statement is only false when the two inputs are false, and that only happens here on the second row. So we can see pretty quickly that these two statements are in fact equivalent. All right, so before we move on to the negation we're working towards, I want to take a minute to think about how we can apply this to rewrite English statements. Right? In this case, possibly because they're so common in mathematics, the if-then form of a conditional statement is very clear to me. So I like to get this or into that format. Now, if we match the sentence up with the or side of the equivalence, you pass the class corresponds to the not P, and you don't graduate corresponds to Q. All right, that means that P must be you don't pass the class. All right, so now we can see that the original statement, you pass the class or you don't graduate, is equivalent to if you don't pass the class, then you don't graduate. Now, for me, anyway, this is a much more intuitive way to phrase this statement, which is kind of the benefit that I'm getting from this equivalence. So now we're ready to see what the negation of a conditional is. Remember, what we're trying to simplify is the negation of P implies Q. Now, according to our new equivalence, this is equivalent to the negation of not P or Q. And De Morgan's law tells us that this is equivalent to P and not Q, which is what we were looking for, right? This is the simplification we were trying to find. The negation of P implies Q is equivalent to P and not Q. All right, so the conditional and biconditional statements are really at the heart of the kind of statements and arguments we see every day in mathematics. In the next lecture, we're going to talk about two new terms. We're going to talk about necessary versus sufficient. And these are often used to state the relationship between statements, and they play off of the conditional and biconditional that we've been discussing for the last several lectures.